Hey everyone, welcome back. In today's video, we are going to solve one of the more advanced problem from LeetCode that is called reverse pair. Now, this is not your standard array problem. In fact, many people confuse it with the classical inversion count problem. But here, the conditional is slightly different, which makes it even trickier. Okay, let me first read the problem statement for you. Uh, we are given an integer array nums uh, and we need to return the number of reverse pair in the array. A reverse pair is defined as a pair of I comma j such that I is less than j and nums of I, like that number, is greater than the 2 times number of j. Okay, now that condition is the whole challenge. At first look, you might think of brute force, that is check every pair I comma j. That would take off and square time, and for arrays with size up to 10 raised to the power 4, that's not absolutely possible. Okay, so our goal today is to reduce this to off and log n using a very smart trick, a modification of merge sort. So stick with me till the end, because not only we will solve problem, but you will also understand why merge sort helps in counting these pairs and how to avoid common pitfalls like overflow and all. And I will walk through step by step code so you can type along with me. Okay, so let's begin. Let's start with an example. This example, we will given an array 1 3 2 3 1. Now we want to find the reverse pairs. So if we can see, here is that reverse pairs are 3, this 3 and this one, because yeah, 3 is greater than the 2 times of 1, that is 2, and the another pair is 3 comma 4, that is 3 comma 1, this one. Okay, so here that because the answer is 2 reverse pairs. Okay, so if we wrote the brute force, we have to do 2 nested loops, right, like this, and just writing the pseudo code, not complete code, because we are not solving in the this code. uh, if nums of I is greater than 2ln. Now why we use 2ll, because we want to not overflow this, so count plus plus. Okay, so if we think about brute force, this works for small arrays, but the complexity here is of n square. Let's say the size of the array is 50,000, then it's around 2.5 billion possibilities. So yeah, this is not optimal solution. So brute force is not the way, but notice something interesting. This condition kind of resembles inversion counting, where we check nums of I is greater than nums of j. This I'm talking about this condition. But here it just is nums of I is greater than 2 times nums of j. In resemble inversion counting, the condition is this: nums of I is greater than nums of j. So yeah, we can think about it. That's the hint. Like we can use a modified version of merge sort inversion counting. Okay, so let's step back and recall how merge sort works. Okay, we divide the array into halves until we reach single element, then we merge them back in sorted order. Now, why does merge sort help with inversion counting? Because when both halves are already sorted, we can count how many inversion exist across the two halves in a smart way without checking all pairs. Same idea here. When we split into left half and right half, all reverse pairs where both elements lie entirely in the left half will be counted when we sort the left half recursively. Okay. Now the all reverse pairs where both lie entirely in the right half will be counted when we sort the right half recursively. Now, what remains are reverse pairs where I lies in the left hand and j lies in the right half. Okay, and here is the magic. Since both halves are sorted, we can use two pointers to count these crossed pairs in a linear time. Say, let's say the left half is 2 comma 3 comma 5 and the right half is 1 comma 4. We want pairs where nums of I is greater than 2 times num of j. So if we start with I is equals to 0, that is 2, and j is equals to 0, that is 1. Check the if 2 is greater than 2 times 1, no, move j, no instead of move I. That's how this reduces the problem from O of n squared to O of n log n. Alright, so let's start coding with this idea. I will write everything step by step. First, basic int count is equals to 0. That stores the count. Basically, that is the answer. We want to return this. Now we make the function merge sort. In this, we will send the vector nums. Start part. Okay, let me define start and end externally so it makes easier for you. Int end is equals to nums.size minus 1. Now we will send start, and also we have to send the count, and in last we return the count. We make the main function simpler. Now the merge sort function, it's very similar to the real merge sort function, not like there is no change actually. So merge sort, here we vector int and nums start in and and count, where we store the answer. So first with the start with the base case, what is the base case in the merge sort? It is also same, and return. Now we find the mid element, start plus and minus start. Sorry, divided by 2. Okay. Now we sort the left part, merge sort, nums, start, mid, and the count. Now we sort the right part. We call recursive function that is very simple, mid plus 1 and count. Now we sort the left part and the right part. Now we want to merge both. So we make another function merge. Here we send the vector nums, start, mid, and the count. Okay. So yeah, this is the all of about merge sort function. Now main merge function with the counting logic. That's asking the question. Void merge. In this, what we are getting, vector in nums and start and mid and the answer. Okay, so we make the variable in j is equals to mid plus, and that points the second variable of this. Now the count, we have to count reverse play across halves. This is the logic for we start with the start variable and move towards the mid, and we check if while basically if j is less than equals to and this is the main logic, nums of I is greater than 2 times nums of j. If we're getting this, then we increase the j while we are getting this, and in last we add the count plus is equals to j minus mid plus 1. Okay, so this is the main logic where we move till we get this number nums of I is greater than 2 times nums of j. We increase the j pointer, and in last we add in the count variable. Okay, after that wait, that's basic normal merge function. I'm writing the code very fast because you all know about this function. So okay, this is the main while loop, and nums if nums of left is less than equals to nums of right, then we push this array, and not push nums of left plus plus, we increase the pointer num left, else temp dot push back nums of right plus plus. Now if the left has remaining, then we make another loop for this, and temp dot push back nums of left plus plus, while right is less than equals to right is less than equals to, and temp dot push back nums of right plus plus. Okay, now for int I is equals to start, I is less than equals to, and I plus plus nums of I is equals to temp of I minus. We copy the temp array into the nums array. So here is the complete code. Now let's run this code. Yeah, it's running fine. So now submit it. Okay, you can see here we can beat 56.21% here. Okay, so let's quickly talk about complexities. Merge sort itself takes off and log n. Our extra counting step inside merge using two pointer, which is off and for each merge. So overall complexity is off and log n. And you can see this is the main logic behind the count. So basic pitfalls to avoid. We integer first is integer overflow. Notice we used everywhere is 2ll into terms of j. Always cast to long before multiplying. Otherwise, 2 times num of j can overflow if nums of j is very large. Oh, next thing is don't forget to actually sort the halves after counting. Otherwise, later merges won't work. Currently, this part, yeah, this part, and make sure you only count when I is less than j. Our recursive structure guarantees that. So this is both optimal and safe. And that's it. We have successfully solved the reverse pair problem using a modified merge sort approach. The big takeaways are here is problems like this often hide a connection to merge sort or binary search trees. The two-pointer tricks while merging is the key to avoid brute force, and always dry run with the smaller examples to gain confidence. Okay, so if you found this helpful, please give the video a thumbs up, subscribe, and share it with your friends who are also preparing for coding interviews. I'll see you in the next video.